section 4.1 and 4.2, where we are going to graph quadratic functions in standard form and using transformations. So the standard form of a quadratic function is y equals ax squared plus bx plus c. The parent function of the family of all quadratic functions is f of x equals x squared. So the graph of a quadratic function is a parabola. So the vertex of a parabola is the maximum, which I will generally call max, or minimum, which I will generally call min, point on the parabola. So the axis of symmetry divides the parabola into mirror images and passes through the vertex. Okay, so let's just graph and then compare. So my parent function is y equals x squared. So I'm going to graph that. So x, y. So 0, 1, and 2. So 0, 1, and 4. So 0, 0, 1, 1, and 2, 4. 1, 2, 3, 4. And since this is my axis of symmetry, I can do it on both sides. I don't have to try all 5 points. I only have to try 3. Okay, so now let's try our y equals 2x squared. So I have 0, 1, and 2. So it's still 0, 0. 1 is now 2, and 2 is now 8. So 0, 0 is the same. 1, 2, and 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. So my lines leave much to be desired, but my points are correct, and that's really what I'm looking for you. Okay, so now I'm going to graph the function y equals negative 1/2 x squared and compare it to the parent function. So I'm just going to re-graph my parent function. So this one's really badly drawn. Negative 1/2 x squared. So x, y, so 0, 1, and 2. So 0 is 0, 1 is negative 1/2, and 2 is 4, negative 2. So 0, 0, 1/2, 2, 2. Okay, so the graph of a parabola is more narrow than the parent function if, like this, the absolute value of a is greater than 1. So 2, 4, any number greater than 1. So the graph of a parabola is wider than the parent function if 0 is, so the absolute value is between 0 and 1. So basically a fraction. The graph of a parabola opens up if a is greater than 0, and this means that there is a minimum value, and the graph of a parabola opens down if a is less than or equal to 0, or less than 0, and this means that there is a maximum value, and it's kind of like a umbrella and maybe a canoe. Okay, so that's that. Hopefully it's not too challenging. So now we are going to do 2 ways of doing it. There are 2 ways to find the vertex of a parabola. Option 1 is the vertex has a coordinate of x coordinate of negative b over 2a. And once you find the x coordinate of the vertex, you plug it into the function to find the y coordinate of the function. The y coordinate of the vertex represents either the minimum or the maximum. Value of the function. So we have y equals x squared minus 2x minus 1. So my a is 1, my b is negative 2, and my c is negative 1. So it's negative b, so negative 2 over 2a, which is 1. So it's 2 over 2, which equals 1. So my vertex x is 1, and for my y, I'm going to have 1 minus 2 minus 1, and that is a negative 2. So that's my vertex. The other option is to use a graphing calculator, and I will show you how to do that. Whoops, clear. So I put in my equations. So I have negative x squared plus 6x minus 8. And then I graph it. And it's really important that we can see the minimum or maximum on our screen, because if not, then our calculator won't know it exists. So then I go second calc, and I want to find maximum because it is the top, and I have to be on the left. So I'm right here currently, so I'm on the left. So now I need to go to the right. So I'm just going to scroll over using the arrows, and I'm on the right, hit enter. Enter again. So I get 2.999999 and 1. I'm assuming that's 3. If this was something that I didn't know the answer was 3, 1, check it, because sometimes your calculator is a little bit off. So my vertex is 3, 1. So the equation for the axis of symmetry of a quadratic function is x equals negative b over 2a, or the x equals the x value of the vertex. So that's easy. So it's this and this. So let's find the examples. So x equals 1 and x equals 3. That is probably some of the easiest points you'll get on the test. So the y-intercept of a quadratic function in standard form is 0c. So we're going to find the y-intercepts for examples 1 and example 2. So my y-intercept would be a 0, and then c, so negative 1, and here it would be 0 and negative 8. Pretty easy, not too challenging. So now we're going to graph y equals 2x squared plus 6x plus 3. My y-intercept's my favorite because that's the easiest, so 0, 3. So then I'm going to find my vertex of negative 6 over 2 times 2. So negative 6 over 4 equals negative 3 halves. So my vertex is negative 3 halves something, but my axis of symmetry is x equals negative 3 halves. So I'm totally going to cheat and use my calculator on this. So I get 2 times 3 halves squared plus 6 times negative 3 halves plus 3. So I get negative 1 half, which is also negative 3 halves, and then I'm going to graph it. So I have 2 points, and then I can use the axis of symmetry to find a third. So negative 1 half, negative 1 half, 0, 1, 2, 3, and it's 1.5 over, so I can go 1.5 over here, and then I can connect the dots. It's not the best you've ever seen, but it draws, it works. Okay, so now let's find this one. Y-intercept, again my favorite, 0, 6. Vertex, so negative 3 over 2 times 2/3. So I get 3 over 2/3, so I'm going to get 9 halves. So that is, hold on, 4, that's 4, so 9/4. Okay, so 9/4, x equals 9/4, and I'm going to cheat again because I really don't like fractions. So 2 divided by 3 times 9 divided by 4 squared minus 3 times 9 divided by 4 plus 6. So I get 2.625, which is more helpful, but I'm going to put it as a fraction for my vertex point. So 21/8. So 9 1/4 is 2 1/4, and then I'm going to go up 2 in a bit. So I'm just going to guesstimate it. So I know this point is 0, 6. So 1, 2, 3, 4, 5, 6, and it's 1, 2 1/4, 3/4. We're going to call that good, and we are done. And again, it doesn't have to be a perfect line, it needs to be close. So that's how we do that with standard form. Now let's try it with transformations. So I'm just going to start filling in. So if I add 3 to the function, it's outside of the parentheses, so that means it's a vertical translation up 3, or we call it up 3. And then if it's a scale change of 1/3, it's going to be y equals 1/3 x squared. So this would be just multiply by 1/3. So, and this would be wider. So if it's 3x squared, it's a scale change of 3, and it's narrower. and this would just be multiplied by 3. Okay, so if we replace x with x minus 2 squared, that would go right too. And y equals negative x squared. We're multiplying by a negative 1, and that would just be a reflection. Okay, and then vertical translation down 2, that would be y equals x squared minus 2, because up or down is outside the parentheses, so we just subtract 2. Horizontal translation left 1, so that would be a y equals x plus 1, because inside the parentheses it seems counterintuitive until you're good to it, so we add 1 to x. Multiply by 2, that would be y equals 2x squared, and that will be narrower by a scale of 2. And horizontal translation right 3, that will be y equals x minus 3 squared, so we just subtract 3. So, from x. So if you are watching the video notes, I'd like you to put a big star up here. Thank you. Okay, so now we are just going to say the transformations. We're going to describe it. So I'm just highlighting the big stuff that we need to worry about. So I have a plus 5 inside parentheses, so that means I am going left 5, and it's minus 1, so that means down 1. So I have a 3, so that means it is narrower, and it's plus 2 outside the parentheses, so it's up 2. Here we have a negative, so that's a reflection. 1/3, so that means it's wider. And plus 1 inside the parentheses means that it's going left 1. Okay, so pretty easy. So here I want to tell you that a equals 2, a equals negative 1, and the a doesn't change there. So quickly write what you think they are, and then I'll check them for you. So thanks for pausing. Y equals 2x minus 1 squared, because the only thing I changed is the a, and then I moved it to the right one, so it's a minus. Here it's y equals negative x plus 2 squared, because it moved to the left 2. Here we get y equals x minus 3 squared, and then it's down 2, so minus 2. And here I have y equals x plus 3 squared plus 1. Thank you very much. And if you could do the back sheet of this, I will have the answers posted online so you can make sure that you actually know how to do it. Thanks for participating. Have a great day.